Hello, geometry students. Mr. Zacek back and better than ever with you here in the next lesson. Just had a little bit of coffee and I'm feeling good. We're going to continue with congruence and right triangles. So when we think about the kind of special case of congruence and right triangles, what we're talking about is hypotenuse leg and the ability to be able to do that. So when we look at this question 1, for what values of x and y are the triangles congruent by hypotenuse leg? You want to remember with hypotenuse leg that there are 3 conditions that are required. Okay. Number 1 is we need to have 2 right triangles. Number 2 is we need to have a hypotenuse congruent to the hypotenuse. And number 3 is we need to have a leg congruent to a leg, and the key here is that they have to be, the corresponding legs. So in this example, what we see here is that the hypotenuse is this side, it's the side opposite the right angle, and that the legs would be over here. So when we set up our equations, if we did the legs first, it would be x equals y plus 1. All right, and then the hypotenuse would be x plus 3 equals 3y. Well, what you notice about this is 2 equations and they both have different variables. I would go ahead and use the method of substitution here. Notice in the first one we've got x isolated, and so we can replace it in this equation down here. We can replace that x with this value right here because x equals y plus 1. So we're going to substitute in y plus 1 plus 3 equals 3y. So that would be y plus 4 equals 3y. And if we subtract y, we get 4 equals 2y. And then we divide by 2. And so 2 would be the value of y. And then to find x, well, x equals y plus 1. So now we know what y is. So x would be 2 plus 1. X would be 3. Okay, so just a little review of some algebra and, systems of equations. All right. So as we look here, are the 2 triangles congruent? Notice what we have over here. In this triangle, we have side-side angle, which we would think would lead us to hypotenuse leg, and over here we have side angle side. All right, so those are not the corresponding, their hypotenuses are not the same, so therefore they are not congruent because their corresponding sides are not congruent. Okay, different combinations. All right, so here we go. Now we have complete the flow proof. In this, PS is congruent to PT. All right, and angle PRS and angle PRT are congruent. So the next one says angle PRS and angle PRT are right angles. Now, here's why. We know that they're given, and we know what? This right here forms a linear pair. All right, so this is one of those ones we haven't used as much, but why is that? Okay, and the reason is linear pairs that are congruent are right angles. So if they're both equal to each other and they add up to 180, then they both have to be right angles. So we could, kind of draw in that box for the right angle there. So therefore the triangles are right triangles, and that's if a triangle has a right angle, then it is a right triangle. Okay. So PSR and PRT are supplementary. Angles that form a linear pair are supplementary. So PS is congruent to PT. That was one of our givens. PR is congruent to PR. That's the reflexive property. And so what do we have going on here? Well, we've got right triangles, we've got the hypotenuse, and we've got a leg. So we've got hypotenuse leg congruent to hypotenuse leg. All right, let's go ahead and do a few more of these. Okay. Triangle LNP. Now, we're trying down here where it says MN is congruent to QP. So I see, first of all, that those are parts. And in my thinking, I'm like, okay, well, I probably need to prove the triangle's congruent first. So let's see how we can get that. All right, LNP is isosceles with base NP. Well, in an isosceles triangle, the legs are congruent. So those two sides would be congruent. All right, then I've got MN perpendicular to NL. So I'm going to call this angle 1. That's going to be a right angle. QP is perpendicular to PL. Call that angle 2. All right, that forms a right angle. And then we've got ML congruent to QL. So here, here, okay? Well, I see that. What's the thing? Side-side angle. Okay, it doesn't work. If it's a right angle, we can use hypotenuse leg. All right, and then CP, CTC. All right, so let's go ahead and do that. So let's do the right triangle part first. So I'm going to say MN is perpendicular to NL, and QP is perpendicular to PL. Why? Given. What do we know about perpendicular lines? They form right angles. Angle 1 and angle 2 are right angles. Why is that? If two lines are perpendicular, then they form right angles. Hopefully in these two lessons you really get this reason down, if you haven't already. If two lines are perpendicular, then they form right angles. Okay, so now what do we know about those two triangles? Well, we know they're congruent. So we could say triangle LNM and triangle LPQ are right triangles. Triangles, not angles, triangles. So if a triangle has a right angle, then it is a right triangle. All right, so we've said they're right triangles. Now let's do the hypotenuse piece of this. So step 4, the hypotenuse is ML congruent to QL. Given. All right, the next thing I'm going to do is the other part, which is triangle LNP is isosceles with base NP. All right, and that was also given. So now, because I know it's isosceles, I can say that LN is congruent to NP. So side LN is congruent to side MP. How do I know that? If a triangle is isosceles, then its two legs are congruent. Okay, so that allows me to say, now we've got the conditions for a hypotenuse leg. So triangle LNM is congruent to triangle LPQ. And we can say that because of hypotenuse leg congruent to a hypotenuse leg. Once the triangles are congruent, then all of their parts are congruent. So our last step, always the thing that we're trying to prove, MN is congruent to QP. And the reason is corresponding parts of congruent triangles are congruent. Hey, that's the reason. Okay. So let's see. I don't think I want to do all of these. 5 is kind of very similar to the other ones that we've done. I do want to do this one because it just adds a little, let's do, we'll do 6 and 7 here. We'll skip 5. We'll do 6 and 7 just because they add a little kind of twist to things. Okay. All right. Again, let's look at what we're trying to prove. We're trying to prove that QP, that segment, bisects SQR. All right. Well, if that were the case, and I'm going to write this angle in here, I'm going to call this angle 1 and angle 2. In order to prove this, I need to show that angle 1 is congruent to angle 2. Well, those are parts of triangles, so we're going to get that by CPCTC. Well, how are we going to get CPCTC? Well, let's go back and see what we're given. We're given that PR is perpendicular to QR, so I'm going to call that angle 3. And PS is congruent to QS, I'm going to call that angle 4. Got a right angle. Okay, then I've got QR congruent to QS, and then my freebie by the reflexive property. So as I look at those triangles, I see side-side angle. Can't do that, but because they're right angles, I can do hypotenuse leg. Okay, so let's go ahead and do this one out. So PR is perpendicular to QR. PS is perpendicular to QS. And in this one, I'll bring the other one here in the given. QR is congruent to QS. Okay, given. All right, now I'm going to go and get the reflexive property out of the way. QP is congruent to QP. Just like to do that to show you that there's different places where you can put these in. We're not always following the exact same order. Reflexive property is one that can, kind of fit anywhere. So now I'm going to say angle 3 and angle 4 are right angles. And here we go. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. All right. And what do we know now? Well, that means those triangles are congruent. So triangle QSP and triangle QRP, I think I just said congruent, I meant to say right triangles, okay, are right triangles. You want to be careful because, you want to make sure it's a triangle when it needs to be a triangle and it's an angle symbol when it needs to be an angle symbol. So the reason is if a triangle has a right angle, then it is a right triangle. All right, so we've got our sides, we've said there. Now we can say they're congruent. So we can say triangle QSP is congruent to triangle QRP. And the reason here is hypotenuse leg, congruent to hypotenuse leg. All right. Once the triangles are congruent, now we know their parts are congruent. So I can say angle 1 is congruent to angle 2. Corresponding parts of congruent triangles are congruent. And since 1 and 2 are congruent, that means that QP bisects angle SQR. And how would we say that? Well, we'd say if a segment divides an angle into two congruent angles, then it is an angle bisector. All right, and we've just proven an angle bisector. So little, more complex little twists there in that one. And let's go ahead here again and do this one, another kind of twist. We want to prove that BC is parallel. Okay, well, how are we going to do that? Well, here's BC and here's AD. How are we going to do that? Well, probably what we're going to do is we're going to prove some angles that are congruent. And so if we could show that angle CBA was congruent to angle ADB, then we could prove that the lines are parallel because the alternate interior angles would be congruent. So we've got angle A, angle C as a right angle. We've got side AB and side CD, and then by our reflexive property, okay? So we've got hypotenuse leg. We've got CPCTC to get this part, which is going to lead us to the parallel lines. All right, I'm going quick, but feel free to ask questions in class. So angle A and angle C are right angles. We know that because it's given to us. All right, what else? Let me put the other things in here. Whoops, AB is congruent to CD. That's our other given. So, you know, maybe we do the reflexive property next. BD is congruent to BD. Reflexive property. Have we done all three parts yet? No, we haven't. We've got the hypotenuse, we've got the legs, but we also need to say that they're right triangles. So triangle BAD and triangle DCB are right triangles. And we know that because they have a right angle. So if a triangle has a right angle, then it is a right triangle. Then it is a right triangle. All right, that's our third condition that we need for hypotenuse leg. So now that we've got the triangles, you know, the three parts, we can say they're congruent. So triangle BAD is going to be congruent to triangle DCB. All right, what's the reason for that? Well, it's hypotenuse leg congruent to hypotenuse leg, which allows us to say that angle CBA is congruent to angle ADB. Corresponding parts of congruent triangles are congruent. Just one thing to note about that, for those angles here and here, that arc has to touch the parallel side and the transversal, okay? So that's one of the keys. That's one of those areas where a lot of people make mistakes there in identifying that angle correctly. All right, now that those angles are congruent, we can say that BC is parallel to DA. And the reason for that is that if two lines are cut by a transversal, such that alternate interior angles are congruent, then they are parallel. All right, so couple of fun proofs. These last two, just putting a bunch of things together, okay? And we're going to have you know, a bunch more examples. You're starting to kind of get a picture of the complexity of how all of this stuff that we've been working on begins to fit together. So please ask and keep on asking. All right, we're doing some complex stuff here. Good luck.